I'm going to give a talk with Maish about, next slide please, about searching outside of the box. And what I mean by that is two things. We're going to look at two things. Firstly, think of the box as your internal content. And what we do is we get very focused on what's in that box. We do analytics on what's in that box. We think very closely about how we can retrieve content from that box. But I want to expand that in searching outside of the box to how can we leverage external knowledge, knowledge that isn't in the box, to help us find out what is in the box. Next, please. The second thing that we're going to look at is search should return answers and not just content. And before we can return answers, we need to understand what questions you're asking. So search needs to understand your question. Now, if you don't think this is important, a statistic for you is 25% of Google searches now are not for content. They're searches asking questions, common questions. So search, we want you to think in terms of searching outside of the box. Think of this as not just retrieving information and retrieving content, but search as a tool for answering questions dynamically. Next. Okay, this slide is one that I often use when I'm talking to clients about doing taxonomy, what's it all for, annotating content, and semantic enrichment. And sort of explain the slide very, very quickly. On the left-hand side, we've got your content, we've got enterprise content, and we've got an enterprise taxonomy. Hopefully you've got one, or if not, you're thinking of building one. But this taxonomy, that is the descriptive language for indexing that content. The right-hand side is what we can do with semantic enrichment, which is we can map your concepts in your taxonomies to the outside world. In the example we're going to use, we're mapping concepts to DBpedia as an openly accessible source of knowledge, general knowledge. When we map your concepts to the outside world, we can answer questions that can't be answered by looking inside the box of your content alone. Next, please, Ryan. Right, so to put a demonstration together for you today for this event, we stuck with news because the news is, everyone can understand the news. It's not restricted to anybody's particular domain. We pulled in from a Signal Media research data set some news articles, 1 million news articles. And with the Corporation of Associated Press, they loaned us their taxonomy collection, which is over 170,000 concepts, people, places, names, and organizations, and thank you, Associated Press, for that. We then mapped some of the Associated Press concepts into DBpedia. So we built that bridge to the outside world, and then we built some experiences on that, which Maish is going to show you. Just one more slide, please, Ryan. Just to sort of show you, the Associated Press taxonomies are rich. We've got a lot of hierarchy. We've got a lot of richness in that indexing vocabulary, and that's key to indexing the content. But what comes after that, when we connect outside of the box, is going to be revealed by demonstration by Maish, and then I'll return in a minute and we'll look at how that works analytically. Thank you.
Thank you. Hello, everybody. Hi. Thanks, Dave. So I'm going to be using a few queries for my demo, and Ryan's going to be typing out the query, so thank you, Ryan. So let's get going. So the first query is Obama meets Indian PM, right? So if you think about that query, it's a general query, and if I type it into a general search engine, it doesn't have much to go by. So what you're going to get is very general results, right? So you're going to get a lot of recall, but low precision. But when we type it into a search engine like this, what do we get? We know it gets resolved into entities. So you type in the general query over here, and the results come back, and you have a profile of Barack Obama, full name, and Narendra Modi, full name, and then that is taken into the search engine, and what you get back is relevant results about the meeting between these two people. And on the left-hand side, something that you're familiar with is our filters. They're coming in from the taxonomy, but these are relevant filters. So every part of the search interface now suddenly has high relevancy. So let me unpack this for you. So what's really happening under the hood? So when we type in a query, a general query for the news collection, you got Obama meets Indian PM. The first thing that's happening is that you try to understand the intent. You're trying to infer the intent. The intent over here is the meeting between two people. It's a meeting. It's two people. And so we try to disambiguate that and say, OK, if that's a meeting between two people, what can I do with that? Now, once I have that, I go to taxonomy and knock on the doors of taxonomy and say, knock, knock, taxonomy. I have two entities over here. One is Obama, and one is Indian PM. Can you help me out? So the taxonomy might say that, well, I have two matches for Obama. I don't know which one do you want, but I have two matches, but I don't have anything for Indian PM, sorry. So, OK, thank you. I'll take those two matches. And then what we do is go over to DBpedia and say, knock, knock, DBpedia, do you have something on Indian PM? And so DBpedia says, well, let me understand that a little bit better, right? And says, yes, I have. I have the name of this, the current Indian PM, and his name is Narendra Modi, and I'm going to give you some more information. You can take that. So you say, thank you, DBpedia. You bring that name back. You bring it. You take the two Obamas from the taxonomy. You bring it back to search, and then you show the search results, right? Now, those two cards that you're seeing over there are knowledge cards. This is something very similar to what Google does with this knowledge graph, right? The information that's shown over there is not in the news collection. It's from DBpedia, right? But remember, I had two Obamas, right? So what we do when you get back to two Obamas, we check with the news collection and say which is the most popular meeting between which Obama and Narendra Modi. And over here, in this case, it is Barack Obama meets with Indian PM. But that's a suggestion given to the user, saying that this is what I think, this is my best guess, but if I'm wrong, you can always go ahead and change it. So who's the other Obama? Well, apparently there was a meeting between Michelle Obama and Narendra Modi, and so we can take a look at that. And that's one result between them, and that's an interesting news article where they seem to have similar dress sense. So OK, so let's take another query. So this is US tennis players, right? So it's a very general query. You type this into a traditional search engine, you're not going to get much. Really, there's absolutely nothing in that query, right? But this is a big collection, so what can we do with it? So let's go through the same process. First stop, what's the intent? What do people really want when they type in such a query? So it seems that they want articles on US tennis players. That's what they want, okay? But I don't know who the US tennis players are. So go to the taxonomy and say, knock, knock, taxonomy. Can you help me out here? I got US tennis players. Well, taxonomy says, but I got a lot of people over here in the entity list, but I don't know if they are tennis players. Maybe they're just athletes, but I can't help you over here. So you tell the taxonomy, wait up, I'll just come back to you. And you head over to DBpedia and say, hey, DBpedia, can you help me out here? I got US tennis players. And you see it in DBpedia way, where you say you use the born in attribute. And so DBpedia says, yes, I got a lot of US tennis players. How do you want them? Say, OK, why can't you give me all of them? And by the way, can you rank them by the titles that they have won? Sure thing. So it gives me the whole list. So I come back, knock, knock, taxonomy, and says, what about these people? And the taxonomy says, hey, you know what? I got results for 3 of them, right? I got results for 3 of them, but 1 I don't have. So here's what it is. And so I take those results back from the taxonomy, go back to the search index, execute the query, and this is something that you get. So if you notice over here, I just typed in US tennis players, and you get the names of US tennis players. And the interesting thing over here is that the last one is grayed out. Why? Because we don't have articles on Chris Evert in the news collection, but we got articles on the first three. Now, you could do the same thing, and you can keep extending the query, make it more specific. So I could say things like US tennis players born in Michigan, right? Now, here's something interesting that happens. You notice over here, Venus Williams disappears from that list, all right? She's apparently born in California. Okay, so Serena Williams is born in Michigan, and I got 3 more tennis players who are born in Michigan. And you can continue again, and I can say, show me tennis players born in Michigan after 1980. And so you see that the list keeps getting narrower, and you get results which are highly specific. So here's a simple demo of what we could do if we, 1, take a natural language query, figure it out, okay, break it down, try to understand the intent, and then take the parts of that intent and use taxonomies and learn from the taxonomy, and then get out to the open web, in this case is DBpedia, learn from that, bring everything back, and offer a rich experience back to the user. So that's my demo. Okay. Over to you, Dave.
Thank you, Maish.
Thanks.
Okay, so just a couple of slides to wrap this up, sort of under the hood, how Maish did what he did. Here in the taxonomy management system, we've got the Associated Press record for Serena Williams, but we've got a mapping to DBpedia. When we're in DBpedia, so we make an OWL same as assertion. My Associated Press record for Serena Williams is the same as yours in DBpedia. We open up a world of new knowledge that we can tap into. So right down there, some things we know her birth date, we know her birthplace, we know that she plays right-handed. We know where she lives, and I can't read the last one, but there's a wealth of information in DBpedia that we can tap into and ask structured questions or query that graph intelligently. Next, please, Ryan. A very important thing that happened there, that happened without you really thinking about it, is natural language search was entered, US tennis players born in Michigan after 1990. And that was processed in a very targeted, intelligent way. And if you can picture doing this without a natural language processor there, an intent engine, as it's called, you'd have an expert sort of user screen with lots and lots of facet filters and parameters that you can combine. And that's great if you're an expert system user, but more and more people want that one box. So what we've done here is parse the user's query in natural language out into parameters and wired those parameters to the graph of knowledge, both inside the taxonomies and in DBpedia, to come out with the precise results. So that's the process. Next, please. Only yesterday, at a coffee break, we heard a taxonomist in conversation just say to us, all too often people put effort into building taxonomies only to find that search then ignores them. I don't know if that's a familiar experience, I know it will be for many people here. Taxonomy and search belong together. They are complementary. And what we hope we've done in our little demo today is show that there is this deep connection. They can work together, and we hope you will love your taxonomies and love your search. We're at booth 201 and here to chat with you after. Thank you.